wait a sec. So there was a question about the okay. So there was a question about this from Wanki. So let me explain. Sorry for bothering. Could you explain why does the pink circle turn green visually? But we clearly realized they were pink in the first place. I'm still confused a little. So, okay, let me explain. So first of all, do you guys get that, you know, each of the frame is like this, static wise. If I don't, you know, play it as a GIF movie, then one part of the circle is missing in terms of pink. Is it clear so far? Okay. Either yes or thumbnail would be great to understand whether you're you got it or not. Maybe I forgot to share the screen. Sorry. So I'm not talking about this lilac chaser. Okay. So in the movie situation on the left, you don't see it really clearly. But if you take the screenshot of that, then you see that, you know, each frame looks like this. One part of the location is missing in terms of pink, but everything else is pink. Clear so far? Okay. So then, even if you look at this here, and then don't move your eyes, what happens? If you don't move your eyes with this, then what I hope you to see is that the periphery starts to fade and the pink starts to become like gray. Correct? So here again, you know, important thing is to look at this and without blink and don't move your eyes. Okay, so Wanki, you got it. Great. Yeah, it becomes gray. All right. So that's itself is called phenomena Troxler fading. Okay. When you are looking at the fuzzy object in the periphery, things starts to fade away from your conscious vision. That's called the Troxler fading. But this, you know, lilac chaser combines Troxler fading with a phenomena called a transient induced fading. So what it means is that because it is changing its frame from one to the next, like this way. Okay. So it's kind of interesting, but if you even if you just flip between this and then this, left and right static image, because there is a transient in seeing, you know, a pink here and not here, or not here in the gray and then pink here. It induces the fading much faster than when you are looking at this thing, you know, statically without moving your eyes. And that's called a transient induced fading. Okay. And then the final component of this illusion is interaction between attention and the consciousness. So I explained the Troxler fading and the transient induced fading, and then interaction between attention and the consciousness. And what it means is that in the case of, you know, normally in your life, when you attend to see things, you see it clearly, right? But there are cases in the everyday phenomena where paying attention to see it makes it less visible. And this is exactly the case where we know that it happens. So when things are fading, paying attention to see it better goes in the opposite direction. And instead, what you actually clearly see is not the pink itself, but it is the after image of the pink, which is normally not that easy to see. And the result of these three components makes it this, quite a striking phenomena of lilac chaser. And probably there is also further unknown mechanism to it, but that's a sort of state of the knowledge that I have about this. Does it make sense better?
But I still have a question. Like, why is the trans to green but not blue or some other color?
Okay. So that's because it's the opposite. It's called color opponency. And that's something that I will need to explain in terms of the color theory. I'll probably do that in next week or so. But roughly speaking, our conscious experience of a color seems to be composed of the two opponent channel, red and then green, and then blue and yellow. And that's the reason, in fact, when you did this, demo, after you saw this for a while, you probably saw something like yellowish like this, right?
Yeah.
And that's because blue and yellow are opposite.
Oh, so, yeah, okay.
Make sense?
Yeah.
And so if you see yellow for a long time, then you see blue afterwards. And if you see green for a long time, you see red or pink later on. Make sense now?
Yeah.
Okay. All right. Is there any further questions so far? Okay. So then let's come back to the question I asked here. So here, so all the answers so far seems to be that if you present something outside of the display, like I now have an orange here in front of me, and if I put my orange onto the side of the display, everybody said that it's visible in terms of color, although cones goes quite low in density. Why do you think, or why did you think that it would be the case? Like at the phobia, on the density of the color, cones are extremely high, and you see color really well, but not outside. So why do you think that you might see things colorful outside as well? Is that because of your intuition or phenomenology? Not clear? Okay. I mean, if you have any idea, then let me know, but let's move on. So far, I take it that you think that you experience color over there, right? And so as I said, in the periphery, you don't have much, color receptive cells. And the summary of this part is that the retina in the eye is a sheet-like structure with the cones and rods. And then your okay, so now I want you to, do the demo actually here. Okay, so again, I want you to do the demo. Now put your finger at the arm's length and then adjust your distance to the display so that fingernail size corresponds to this figure, roughly speaking. Can you do that? So extend your arms like this, and then move your chair or desk so that, or display so that it is roughly matching in this size. Okay. All right, then. So I hope that everybody is ready. And then, what do you see if I show this? Okay, so ready? 3, 2, 1, 0. Did you see color in the periphery? Okay, I'll do it again. So one more time, extend your finger at the center, and then that's roughly where your cones are, located. And then now I present the color in the periphery. 3, 2, 1, 0. So, okay. I hope that you remember what you are experiencing right now. This is how it was like. And then you can move your eyes and then see what's there. And then compare that with one more time. Again, put your finger over there at the center, and then I'll project something on the display. 3, 2, 1, 0. Okay, do not move your eyes. 3, 2, 1, 0. So, okay, let's take the poll. So here, this is an introspection question. Did you see any color outside of phobia? A, yes, clearly. And then B, no color at all. And then other is yes in one case, but no in the other case. Yes and no. Is the question clear? So when you saw two types of the display, did you see color clearly in the periphery for A, and then not at all B, and then yes and no for other? Okay, so A for majority and then other for some people. So what I hope you to see is that here you do see color like thing, but it's not really clear what color you're seeing in each of the location. But probably you saw something like colorful, right? The other case here you probably were able to see that there was a clear color in one location, and then even if I ask you to name the color, probably you are able to do that. So what's the difference between this case and then this case? That's a question. Okay. But in any case, the important thing so far is that you yourself phenomenologically checked whether you see something in the periphery, either sharply or not. And then you can probably show this to your family or friends to see what they experience. The important thing here is that you introspected your color experience at the fovea and the periphery. And then this is the important kind of starting point for the next discussion. So what is our peripheral visual experience like? And let's introspect it. And we already did that. And then here I skip the demo because you already kind of did that. But if you have a fruit like this, pear or orange, and then you can do this kind of experiment. And you can also do with cards, trump cards and so on to check your experience. So in the case of the orange, for me, the size of this orange is roughly like 5 times of my thumbnail. So it's roughly 1.5 times 5, which is 7.5 degree object at this location. And then if I move this to somewhere in the periphery, then if my color experience declines like this way, then I should lose color experience of the orange really quickly around here, and so on. That has been resulted in this type of the demo where you are told that the color is something that you lose in the periphery, but your motion is still something that is visible. But as long as you use this kind of large object, if you try it by yourself, then it may not be the case. Okay, so here, if you have a friend or family who can present some kind of colored object, like either using iPhone or fruit to show which one you see in the periphery, you can see. But as long as the object is relatively large, like in a fruit, you probably see things in the periphery in a colorful way. But once it starts to be a little bit smaller, like a pen or let's say small cup or something like that, then that color in the periphery becomes very unclear. So that has led to many people to talk about the illusory nature of the color. So some of the theories about color, as I review here, says that your impression of seeing color all the way to the periphery is illusory, according to these type of theories. And they suggest that the multiple possible mechanisms underlie the illusion. And one of the explanation is that it's unconscious eye movements or expectation or memory. And we'll examine each claim a bit. So let's examine the plausibility of this explanation. Here's one of the current most influential and famous philosopher called Daniel Dennett. And if you go to the link here from the slide, then you can see his interview with Sean Carroll on the Mindscape. And then around 1:30, 1 hour and 30 minutes and so on, 1 hour and 30 minutes, he talks about that color is believed to be extending into our phenomenology, but it's not. So he has been claiming that our consciousness is illusory. And the term of qualia or consciousness is ill-defined. That's his philosophical position. And this is another color philosophers who is quite prominent in this field. And he says that a periphery presented color sample will match several distinct centrally presented samples equally well or equally poorly. Because if it were to match any one of them, as well as any one of them could match another centrally presented sample, the peripheral sample would no longer appear indeterminate. So this means that something that is presented at the fovea and the periphery cannot be matched in color. That's what he says, because the peripheral color is so fuzzy and ambiguous. This is another book that was relatively published relatively recently by cognitive scientist Nick Chater. He won quite prestigious award recently in cognitive science, and this is a book that is selling quite well. The Mind is Flat. Within that, he says quite extensively that our consciousness is illusion. And one quote here is that one much discussed reason that you should be suspicious of your sense of a detailed and multicolored sensory world comes from the basic anatomy. And what he talks about is basically this, figure. This one, okay? Anatomy-wise, the color cone should degrade quite sharply, and that's what he says. And because of that, he says, indeed, outside a few degrees of where you are directly looking at, meaning that, at the arm's length or somewhere close to fingernail, that's where you can see color. But outside of that, you are close to being completely colorblind. And this is something that you might have, you might see in the future if you read this type of the books and also other types of things. And it's relatively dominant in the cognitive psychology or psychology, sensory psychology textbook. But you're in a sense pretty good at naively looking at your own experience and then examine whether this is reasonable claim or not. And in fact, all of them, you guys said that you do see color outside of the display, and you believe that this density of the cone type argument doesn't make sense. But we'll go into a little bit deeper for that. Okay. So I'll just skip. One possibility of the thing that these people have claimed is that we feel like we see color in the periphery because we are unconsciously making the eye movements a lot. And so if that's the case, then it's almost like a refrigerator and its light. I think you guys have a refrigerator at home, and when you open it, you see the light is there. So whenever you open the refrigerator, it's lighted, right? And based on that, some people might mistaken that refrigerator inside is always, bright, with the lights. However, if you know a little bit about sort of the circuitry, it's written just because when refrigerator is open, door is open, this mechanism actually turn on some circuitry and then make it lit within the refrigerator. So it's only lit when you open the refrigerator, and then something similar happens in the color on the periphery. When you attend to it, there is a color there, but in fact it's all illusory and the gray scale. That's what they are claiming. And in fact, if you think about eye movements, it's quite striking that your eyes, in fact, move roughly 3 times per second, but you are usually not aware of it, right? And in fact, you are not also aware of your own blink as well. The frequency of the blink differs depending on each person, so I don't have a good number here, but you are almost never aware that your vision is actually blank or black, once you blink it. And why is it possible that we don't notice it? And the reason is that there is a phenomena or mechanism called blink or saccade-related suppression in the conscious vision. So this is one particular example of the experiment where you make an eye movement to this central point, and then depending on the eye trackers detection of where you are and in which timing that you're making eye movement, this experiment flash something in the particular location, and then subject said that, oh, there was a flash or not. Okay, and then if you do this type of experiment, then it turns out that time 0, when you start to move your eyes, like let's say if this is the location of the eye, and then here this is moving to this location. Let's say this is a position A, and then this is a position B. Okay, so 0 is the time when you start to move your eyes. Then probability that you see this, white square goes quite low, and then chance performance is here. So meaning that it's basically undetectable, depending on the also contrast and luminance of these things. But it goes from 100% correct to chance performance around roughly 30 to 30 milliseconds or 40 milliseconds after the onset of Sakka. And it's also interesting to see that our vision also start to become quite bad, roughly like 50 milliseconds before, and also up until 100 milliseconds after we make an eye movement. So, and we do this 3 times a second. It's almost like, our conscious vision is edited version of some kind of, very brief interruption of the visible thing stitched together. And then during this blank period, your sensory input before and after gets sort of smeared out. And then that's what you are experiencing. And so all of this suggests that, you are actually making lots of eye movements, but you don't remember and you can't really notice these things. And that's what they are suggesting. So far, it's okay. Is it clear, or was it too fast? Okay, so I guess I think it's fine. So how to counter for that? Yep.
I had a question in the chat.
Yes. Yep. Wait a second. Maybe I didn't see it. So every time you move your eyes, you're blind for 150 milliseconds. Roughly, yes. But the important thing here is that, while your sensitivity to the input from outside goes down, your conscious experience continues, right? So that's what you are experiencing. It's not like you experience blank and then seeing, blank seeing. Do you agree? Yes. And one thing you can actually check here is it's probably this one is actually interesting for you to do. Okay, so if you have a friend or record your face with videos, then well, maybe I can do it for you actually. So I'll just stop sharing and then see my face. Okay, and then I will make an eye movement from the point of my left eye to right eye, like this. Can you see my eye movement? Yes? Okay. Once again, 1, 2, 3, 4, 5, 6. So amount of the eye movement or speed of the eye movement is slow enough that you can see, right? However, if you try it by yourself, maybe use your Zoom. Zoom is actually not good because I can actually see it. But if you go in front of the mirror, then that's much more interesting. In front of the mirror, you realize that you can't see your own eye movement. And that's because before and after your eye movements, your conscious experience is kind of edited out and then chunked it together so that you see continuous phenomenology. Is it clear? Does it make sense? Just to make sure. Okay. So you can't see your eye movement because you are blind when you move your eyes. Yes, 450 milliseconds. Yes, that's right. But it's not because your eye movement itself is too fast to see it or too brief to see it, because you could see my eyes moving, right? But in fact, when I move my eyes on the display, I couldn't see it because for my consciousness, it's suppressed and then edited. So I hope that was clear. Okay, got it. All right, then let's move on. So to the next component is the last part of today's lecture, okay? So so to convince these people who are skeptical about the conscious experience of the color in the periphery, Ariel did the following experiment. So Ariel is the one who did that blue-green experiment at the phobia. Okay. So here again, the similarity rating is the one that we asked people to do at the fovea or close to the fovea, and also slightly periphery, like 10 degrees from the fovea, where the cone density should be very, very low. And then stimulus locations are, first of all, importantly, it's random. So you can't expect or you can't memorize the experience of the color. Okay. And also duration of the stimulus is short enough, only 250 milliseconds. So it also even doesn't produce any after image, unlike red, pink versus green kind of stuff that you saw as a relax chaser. And then also eye movements will not be possible here because 250 milliseconds is too short for you to know the location of the stimulus and then make an eye movement towards it. And also because we presented the stimulus always in the diagonally opposite location, you can't see both with the fixation, okay? And so, expectation and the memory cannot help us because, it's always random across the trials. And this is the demo of the experiment. And it's much longer than the actual experiment because this is for the demonstration purpose. So what do you do? Here is that, look at the center and then compare the two colors and then report a dissimilarity. So let's say this is a pink and the red. So I would say it's 1 or 2. And then this is a green and blue. So it's not similar. I would say 5 or 6. And this is green and green. So maybe I say 0. It looked almost identical. And this is green and pale blue. So it was like maybe 4 and something like that. Okay, did you get this task? All right, yeah. So then the idea is that if our conscious experience of the color is based on expectation, memory, or eye movements, we should not be able to do this task. However, what Ariel found was the following. So if both of the stimulus was presented at center and the center, then as you might expect, only these similar pair, red, red, or orange, orange, and the green, green, they result in this dissimilarity of 0. But blue and then green result in dissimilarity of 7 and so on, right? Critically, when we compare that with the peripheral stimulus, right? So the peripheral pink and then peripheral pink was, first of all, matched in terms of the similarity. So this was very, similar. And more importantly, peripheral pink to central pink was matched. And in fact, if you see the pattern of the result from here to here, central periphery or periphery periphery or central central, they look the same basically. So this is the opposite of what the color philosopher said about matching of the color between central and periphery. So this proves that eye movements or unconscious editing of the vision or expectation or memory does not provide an explanation, but it is genuine that the peripheral sensation or color is true. Then the next question is, how come this is true if the color density of the cone is much lower in the periphery? And to answer that, we need to understand the structure of the visual system, and that's something that I'm going to explain next week. And I'll finish it today here. Okay. So is there any question or comment so far? Okay. Thank you for coming, Liping and also Wanky and yeah, Lisa. Thank you, and hope to see